If you're going to set up a file server, it's a good idea to have a RAID array or a redundant array of independent drives to give you some redundancy and or speed increases. Now, the RAID levels, meaning like the names of the different types of RAID, can be a little confusing. So we'll go through them and I want to talk about some of the pros and cons of each one. But in order to demonstrate it, I'm going to go back to a method that I used several years ago. If you've been training with me for a while, you may remember my awesomely drawn dragon here. And the idea is the dragon wants to get the king. Okay, the dragon represents disk corruption and the king represents our important data. The only thing in between us and the crown are all of our various knights. Now, the first type of raid that I want to talk about isn't really raid. It's just called JBOD, or just a bunch of disks. And what happens here is, let's say all of our knights are each hard drives. Okay, so these are our hard drive knights. If you use a JBOD technique or just a bunch of disks, you get all of the space available on all the drives because we're just adding all of the various drive space together and we get to use all that. The problem is there's no redundancy. If any one drive or knight fails, the dragon can get the king. So there's no redundancy at all. And when you just have a bunch of disks working together, there's no speed increase because if you're writing a file, it'll write to the hard drive. And then when that hard drive gets full, it'll write to the other hard drive, but it still just writes one hard drive at a time. There are no size constraints. So it's nice you can have like a 5 gigabyte drive and a 200 gigabyte drive, and you don't have to worry about sizes. You just kind of mash them all together. But it's that single point of failure that really makes JBOD a bad idea. Now, a similar situation using actual RAID is called RAID 0, which is striped. Now, what striped does is it takes three of our drives, or actually just more than one drive. In our case, we have three, and it combines them all into one drive, just like JBOD does. But the difference is it will write to all three drives at the same time. So let's say you have a 15 megabyte file. It's going to write at the exact same time 5 megabytes on each drive. The advantage there is you get 3 times the speed because you're only writing a third of the file to each hard drive. So they all work at the same time. So it's very fast. The downside is there's no redundancy. If one of them fails, all of your data is corrupt and the dragon gets the king. So there is that single point of failure, but you do get to use the total space because all of it gets added together in the stripe. So I mean, that's an advantage, but really that no redundancy makes RAID 0 kind of a scary endeavor. Unless it's not valuable data, it's something that's ephemeral and you want it to go really fast. In that case, RAID 0 is a perfect idea. And just as a little mind trick here, I like to think of the number after RAID as how many drives can fail. So RAID 0, 0 drives can fail. If we go to our next RAID level, which is RAID level 1, we can have one drive fail or more than one drive. But if we have what's called a mirror, that means that every single byte that you write to a disk is written to both of the drives. So that does limit the total capacity because let's say these are both 10 gigabyte drives. Even though we have two drives, if they're set up in a RAID 1 mirror, we only have 10 gigabytes to work with because it's written to both at the same time, the exact same data. Now, this gives us a limited capacity, but it gives us redundancy where either one of them can fail and the dragon still can't get through because there's still somebody protecting. So the redundancy is really what makes RAID 1 awesome. There's no speed boost. It may seem like it since they're writing to two different drives, but it's writing the entire file to each drive. So there's no speed increase. They're both going, but they're both doing the entire file. So there's no speed increase. But again, you can lose all but one drive. You can have, multiple, more than just two in a mirror, and you can lose all but one. All you need is to have one drive not fail, and your data is fine. Now, what's really common and what a lot of NAS devices use is something called RAID 5. Now, RAID 5 uses a concept called parity that I'll admit is really complicated, but it's really awesome because what it does, it allows you to take, in this example, we have 5 drives. You can have the total drive capacity minus 1. It reserves 1 drive's worth of space for what they call parity. So if these are all 5 gigabyte drives, we have usage of 20 gigabytes. It just takes one of the drives in order to get that parity going. The really great thing is it's faster because it stripes across all of the drives, and we have the ability to drop any single drive. And that's where the magic comes into play. RAID 5 uses parity, which means if this night dies, our data is still fine. If this night dies, our data is still fine. All of the data on there is still fine. You can't lose more than one drive, but it doesn't matter which drive you lose, you're still protected and the dragon can't get the king. So RAID 5 is very, very common. And I just want to note that RAID 6 is the same sort of thing, but it uses 2 drives worth of data as parity. So you get the total drive space, or the total drives minus 2 capacity, and you can lose up to 2 drives. It doesn't matter which 2. So if this is a RAID 6, we only have, if these are 5 gigabytes, we only have 15 gigabytes of space to work with, but we could lose any 2 nights and the dragon still can't get through. We still have all of our data intact. And then lastly, just really quick, is the concept of combos. So you can actually do a RAID 01 or a RAID 10. So you can do a stripe of mirrors or a mirror of stripes, and you get the best of both worlds in that you get speed and redundancy. The only problem is you lose half of your capacity if you're both striping and mirroring, right? Because any of these can fail and it's still fine. You get speed and redundancy, but you lose a lot of drive space. This is really common if it's data that is very, very, very important and you don't want to lose any, but you still need performance. Now, I know that was a lot to take in, but RAID levels are really vital to understand so you can make the right decision with how to best utilize the hard drives that you have available to get the speed that you need, but also the redundancy that's important for important data. I hope this has been informative for you, and I'd like to thank you for viewing.